we made the wrong call taking out a Detroit diesel 12V71s? That's been one of the biggest questions since our last video. And with the ECU gremlins we've been chasing, a lot of you are wondering if we should have stuck with the old Detroits instead of going down the repower path. So today, we're tackling those questions head on, along with a few other questions you threw at us. Could we spin an AC motor or generator off a jackshaft? And could engine water loops actually heat Tangaroa? Then there's the question of the day, all about grounding. And it's a good one, but you'll have to watch until the end to see Blaine's answer.
Hey everybody, welcome to this week's question and answer. As you can see in the video, things didn't go exactly as planned when we went to go leave Montague Harbor. Fortunately, we were able to get it resolved pretty quickly, and the boat actually did really well on one engine anyway. But definitely got a lot of comments from the mechanical diesel crowd on that, which I'll give a response to those as well in this Q&A. But let's go ahead and get right into the questions here. First question up is from Dwight Brown 2808. He asked, do you all have ham radio licenses? HF radio, high frequency radio, might be helpful in the middle of nowhere. We don't have ham radio licenses. That's a little bit more of a difficult thing to get. Not overly difficult, but it takes more. We do have licensing on board for a single sideband though, and we do have a single sideband. It was on the boat when we bought it, and we do have a new antenna for it as well, which we'll be installing again before we leave on big trips across big portions of water, probably in the boatyard this winter, because we will be hauling out in January, hopefully. So yeah, we'll install it then, and then we'll have at least some sort of a radio that'll be better for long-range use, but unfortunately, not a ham radio. Okay, next question up from Rick H 3694. Here's a good one. How do you get your mail statements, campaign ads, AAA ads, life insurance ads, bills, and so on? Fortunately, and you can see where I'm sitting right now, we still have a house in Victoria that our son lives at, and he collects all of our mail for us. Kind of goes through it. Anything that's important he can forward on to us, but typically it's just letting us know what's here, and most of it is not critical anyway. So we do have access to it if we need to, but usually we don't need to, so that's a good benefit. And like I said, you'll notice I'm here in Victoria right now. I had to fly back from Prince Rupert to do a little bit of work on a car here, just a little bit of finish up work that I was hoping to have somebody else do, but unfortunately that didn't work out quite well enough. So yeah, I'm back here for a couple of weeks, or actually pretty much just 1 week to finish that up and get it off my plate. So I'll be back on the boat in another week here. Next question up we have from KKM. Where does the dog do its business on the ship? Fortunately for Maggie, she's a pretty smart dog, and we've managed to get her peeing on a fake grass mat, and we usually put some absorbent pads underneath. The absorbent pads work great. The grass can get a little bit stinky, so we do have to clean it occasionally with some, baking soda and water and soap, but better than the alternative of having her pee where she's not supposed to. She's really good with it. She knows that that's her place to go, and the only time she ever has accidents inside is when we forget to bring the pad inside at night. So she is awesome for going on the pad, and she will go and scratch at the door when she's ready to go out and use it when it's outside. So she's great that way. Next question up here is from Fred Stevens 6793. No cell service. Do you have a Starlink dish? Simply configure your phone for Wi-Fi calling, then it won't matter where you are. On an iPhone, this is in the settings cellular Wi-Fi calling, and also in this option is where you set your address for 911 emergency services. Not sure how you would encode the lat long. The only drawback to this is when you are connected to a really bad Wi-Fi with very low throughput. We actually do have all that configured. It's just at the time of filming this video, I didn't have it enabled on my phone, and with my phone and my carrier, you have to be connected to a cell service to enable the function. Once it's enabled, it works anywhere, but you have to be connected to enable it. And at the time, we didn't have that connection, so I didn't have it enabled yet. But all fully functional now, and has been working super awesome on the Starlink, and we're very happy with it. Okay, we got a question here from Brent McMahon, 8188. Why didn't you just get a marine ECU from Cummins to start with? The custom ones seem to be a real pain in the ass. The main reason is because they couldn't do what I wanted to do with them. They are very rigid and fixed in what they can do, and that's pretty much just running the engine. Doesn't do transmission controls, doesn't do integration with other systems in the boat like I want to do, and it is completely untunable to the mere tuning mortal. If you have access to fairly advanced tuning hardware and software, you can do some changes on those, but not interested in that. Another big benefit as well is with the aftermarket ECU, it's a lot easier for me to diagnose problems, and I can get away with a lot more with basically bypassing certain sensors in case of failures. So it gives me a lot more flexibility there. Like I said, I'll get more into the other aspects of what people have been saying about, oh, you're having so much trouble with it. But basically, yeah, there's things that ECU can do that the factory ones cannot. And there are things that I want to have the ability to do. So yeah, no go for the factory ones there. And you know what, honestly, while we're on that aspect, I will go ahead and address the other comments. I get a lot of the mechanical guys, love you guys, mechanical diesel guys. They love to grab onto anything they see as a failure of the electronic engine. And I just wanted to address that real quick here. What you're seeing here, for starters, is research and development. This is not something that you're going to see on a factory ECM, at least not with any major occurrence. If I had got a factory QSP engine with a factory ECU, I would not have had to deal with any of these issues. That would have already been done from the factory, and it would have been smooth sailing. But like I said, I am doing R&D. There aren't many people, if any, that have done this specific thing on this specific motor in my specific application. I am basically learning and designing around what I have available to me. And that's going to come with some bugs, and there are bugs that I'll have to work out. Now, on that note, a few of the things that you've seen here, that's not even related to the electronic engine or a failure of the electronic engine. That's specifically related to the tuning going into that engine. And like I said, factory ECUs, you're not going to have to deal with that. This most recent failure, if you want to even call it that, was not a failure of the engine. It was not an issue with an electronic engine. It was my learning with this specific ECU. I did something wrong with it, which caused it to get corrupt firmware. It wasn't anything to do with the ECU just failing out of the blue. This is something that you do have to deal with aftermarket ECUs. Usually they're not quite as sensitive to things like this. So I'm a little bit disappointed with the fact that it's easy enough for me to cause that problem in the ECU, which was basically boiled down to I did not properly flash the ECU with upgraded changes that I had made. I'd forgotten about it. I forgot that it was in flash mode, if you want to call it that. It was the ECU required a reboot. And usually the ECUs that I've dealt with in the past, once it gets to that prompt, you don't have to do anything more with it. It just requires a power cycle, which I wrongfully assumed on these ECUs. They require the action to be completed and have the ECU reset itself. So, like I said, I caused that problem. It wasn't a problem caused by the ECU. So for everybody out there saying, oh, you should have gone with the mechanical diesel, you know, the electronic diesel, that's a problem with it. No, it wasn't. That's just the way that I've chosen to do things. And it's research and development that I'm working through and learning this specific ECU. So much as I know you guys like getting up on the mechanical diesel high horse, no, that's not what's happening here. These ECUs have been running for 3,000 nautical miles now with zero further issues. That R&D stuff has pretty much been worked through, and I've had no further issues with them. The only issue that I've dealt with on these engines is a leaky fuel rail sensor on the fuel rail, and that was due to the fact that I had that all broken down into pieces to paint the fuel rails. If I had never taken it off, it would have been ages before I had to deal with that specific problem. So, like I said, know you guys like to pick on the electronic engines. That had nothing to do with it. This was a me problem, not the engine problem. So yeah, that's pretty much rant off. Silverado 123 asked, maybe I missed it, but wondering whatever happened with the propellers that got stolen. Long story short, nothing. We received no further communications from the Richmond Police Department. As far as I'm concerned, nothing else ever happened with it. There were no reports of them getting turned in. So yeah, no propellers. Sadly, that chapter is over. We've turned the page, and unfortunately, we've got to move on. We did have another question. Unfortunately, I don't have it with me. Someone asked about insurance on that. Unfortunately, the deductible on our insurance just made the whole process not worth it. So like I said, we've moved on. Fortunately, they were our spare propellers. They're not our main use propellers, so we just have to live with that. Okay, good question from Pippi626. Are you going to be welding a brake rotor on each shaft with the brake caliper to be able to stop a propeller if need be? Looks like you have dinner on the lines. Yeah, that was a lot of little skeleton shrimp on there. I did debate putting some sort of a shaft stop on there. Mainly would have been some sort of a rotor and a caliper, like you said. How I'm going to do that, I don't know yet. Quite honestly, I'll probably just make an adapter that bolts to the coupler somehow. Who knows? We'll see. But there's a few automotive manufacturers that make electric parking brakes now, and I figured something like that would probably work pretty well in this application. I think Wilwood makes one where you could just flick a switch and it would automatically clamp down on the caliper and be good to go. Once it's clamped, it doesn't need electricity anymore. So it would be a pretty good option, I think. But I have thought about it, just haven't 100% nailed down exactly how that's going to work yet. Okay, we've got a question from Mr. This Is Me Too. Any regrets not going with mechanical diesels? I know efficiency will come into play, but just the $770 for the ECU alone would buy a lot of fuel. Honestly, no. I've got zero regrets. There were some R&D in it, and just in case there's some people that don't know already that haven't been following the channel, these videos are a few months behind, quite a bit behind actually. We're actually up to about 3,000 nautical miles on these engines, and after that bit of R&D on this last video, things have been, knock on wood, pretty smooth. We've had zero issues with the electronic stuff. They've been quiet, they've been efficient, they have worked phenomenally well. So no, I've got zero regrets with any of that. Not that I have anything against mechanical engines, but these have done everything that I've wanted them to do, and they've done it well. So no regrets whatsoever there. As far as the cost on the ECUs, I do carry a spare set, but there was the initial cost of, I guess, like you said, probably around $770 US or so for those, or $1,100 US. I can't remember exactly what they were. But quite honestly, that is a pretty paltry expense over the long term of the engines. I mean, if you factor that expense over a 10, 15 year, 20 year range, that's pretty minimal. That's not a massive expense. And with the fuel economy that I've got over the Detroits, that gets paid off pretty darn quick. We're roughly around half of our fuel burn from what we had with the Detroits. So yeah, there's no regrets whatsoever. And on that note, just to give you guys an idea, we hold 3,000 gallons of fuel. And I think typically when we're fueling up, that ends up being in Canadian dollars somewhere in the $15,000 to $18,000 range. Yes, you heard that correctly. Fortunately, that fuel lasts us a very long time, especially when we're not moving a lot. If we're doing short trips, spending a lot of time in places, especially when we're around Victoria, that would last us for well over a year, coming on close to 2 years. So yeah, $770, $1,000 for an ECU, pretty small pittance for what we save in fuel over the course of the lifetime of these engines. All right, next question we got up here is from Jet Driver. ECUs have a learning curve, but as your comments demonstrate, once you climb that hill, there's a reason all modern engines use them, and it's not just emissions. I'm curious why you don't have hot water on board. Any other significant hotel systems that aren't working? And what's the plan for the big alternators that you have going on the engines? So just to address the initial comment there, yes, there's definitely a learning curve anytime you work with a new ECU manufacturer, and also there is R&D, like I spoke about earlier. You can't just expect everything to work hunky-dory when you're doing as much custom stuff as what I've done here. If I had just gone with plug-and-play engines, I wouldn't have had to do a lot of that, but I would have been capped to the abilities of those factory ECUs, which is something that I did not want. So for me, a little bit of R&D, and the cost on this, I mean, I was already planning on having spare ECUs, so, you know, having 2 ECUs fail, not a big issue because I sent those back to Balder. Balder has not only repaired, but upgraded those free of charge for me. It just has worked out. It cost money to ship them over to Balder in Iceland, but he handled the problem with 0 issues, and super happy with that. Now, to go on to hot water. We actually do have hot water on board, and the only reason we didn't have it in this particular video is because when I upgraded the fuel manifolds in Steveston, where we had the boat hauled, I hadn't got that system connected again yet. And when we were in Steveston, we had showers there that we were able to use on shore, so it wasn't an issue. It was just a matter of connecting up fuel feed and return line back to the heater again, though. So that was handled pretty quickly, and we had hot water again after that. And it's all a hot water on demand system as well, so it works really well. Minimal energy burn for when we want hot water. So for us, it's a good system. Significant other hotel systems? Not really. I think the only other bigger system that we have on board that's not working, and it's not really even required for what we're doing right now, is our dive compressor. We do have a dive compressor to fill our dive tanks, and it's currently got no power run to it. As far as I understand, it still works. I have not tested it yet, but once I run power back to it, it will be fully functional again. Another one that comes into mind is the aft anchor system. I need to run more 4-aught cable back to the back of the boat from the battery bank. So that's one that doesn't work, but once again, not really required. It's a nice to have feature, not a requirement. So that's pretty much it. Everything else works fine. The critical systems, solar, water maker, hot water, heat in the boat, all that stuff is fully functional. Now, as for the big alternators, plan is to have those mounted off the front of the engine, so they will basically be being run in reverse. Doesn't matter with these, they don't have directional fans on them, so they can be run in either direction. They produce the same output wave to the rectifiers and then the same DC voltage out. So they will be extending off the front of the engine, off of brackets, and then they will be driven off the balancer on the front of the engine. Big issue that I'm having right now is that the belt that's on the balancer currently does not have enough traction on it to be able to run these big alternators. So what I have to do is I have to run a second pulley system off the front of the balancer, and I have not yet found something that's going to work for that. I did speak with a company that makes mandrels for like dry sump systems for race engines. They can do pretty much anything. A, it's quite expensive. B, they didn't seem to really want to do it. And C, it's just going to require a lot of headache to make custom pulleys. So I've been trying to kind of find something off the shelf, and I've been kind of balked on that. So I am going to end up having to do something custom for it. And I just haven't gotten to that yet because it's an enormous pain in the ass. To further add to that last question, M. Sabia1 asked, have you given any thought to running a jackshaft or belt off the engine to spin an AC or motor generator? I haven't looked into specifically AC on that. I know that in the automotive world, we've got lots of options for motor generators for, you know, start-stop vehicles, things like that can add a little bit of electric onto that. I haven't really looked into that. Those are mostly DC. But I haven't looked into anything AC related. I could theoretically run something off the back of the transmissions. They do have a PTO output. I could run something off the front. If I'm doing it direct AC without an inverter system, then I'm specifically limited to RPMs that are capable of the generators, which are 1800 RPM typically and 3600 RPM. 3600 RPM, going to be too much to run on my engines, and 1800 RPM, I could do that, but I would prefer to just run a DC generator off of there, like an alternator, and then just have my inverters handle the AC side of things. So I have thought of stuff. I've thought of jack shafts on there. I've thought of belts, which I was just speaking of. I just haven't nailed anything down yet. So that's all still stuff that I'm working on, and hopefully we'll have something figured out fairly soon. Okay, next question up we've got from Madman Eligic. Could you use heat exchangers on the water loops of the engines and then plumb them into the hot water system so you could have showers while you're underway, like heating up a boiler with the engine? My engines do have or my heater does have the ability to run a heat loop from the engines, and I might do that at some point. I haven't really decided yet. We're so infrequently running the engines that I don't know how beneficial it's going to be. And our main heater is an on-demand heater, so we don't have to keep a hot water with an electric element. It just runs off of diesel. So as far as what we've got, it's pretty much we can have showers whenever, and it's only going to run that heat when we have the showers. So me plumbing into the engine just really hasn't been a big priority just yet. Okay, got actually a really good question from Selkie Main. What provision do you have to keep water out of the genset exhaust stack when it's not operating? I realize you could throw a can over the end, but that seems inelegant. Or is it run often enough that you don't risk issues? So when I designed that, or not when I designed it, when I found a good design for that exhaust online, the way that it's done is after that bend that you saw, so basically the tip of the stack, there's a chunk of tubing about that long before the next weld. Inside of there's actually a transition cone that drops down to a slightly smaller size, and there's a tube within a tube in there. So that pipe comes up this way, and then there's a transition cone welded, and then a small pipe welded to that. So basically, in itself, it's already a complete exhaust system. And then there's another big pipe welded over the top of that, and that inner pipe is fairly far down within that pipe. And then on the bottom, where that transition cone welds to the original, the initial pipe, there's a hole drilled in where the big pipe comes in. So basically what happens is any water that gets into that stack, like it'd take a lot to get back into that second pipe, any water that gets into that stack goes down that outer pipe and just drains out the bottom of it. So there's no way for it to get down to the generator. So as you were saying, can over the tip of it, inelegant. This is an elegant way to do it where you don't have to mess with it. You don't have to go up there every time you're done running the generator, put a can on it, and you can leave it for prolonged periods of time, not have to worry about getting water in it. I found that trick. I'm not sure where. I think maybe it was an online blog or something, but made a lot of sense and has so far worked really well. So highly recommend that to pretty much anybody. So Liam Greenwood asked, I didn't quite follow the ECU issue. Did you have the engine running, then make the change to the ECU that required the ECU to restart and stop the engine without doing the restart first, and that bricked the ECU? So stopping the engine doesn't drop power to the ECU. Yeah, you kind of hit the nail on the head there. Basically, I made a change to a setting, and then it pops up with a little prompt on the screen and said that the ECU has to be reset to make that change. And from what I've learned, when you do that change on the ECU and let it do it itself, it just sounds really harsh on the ECU because it's doing that reset when you're underway and the engine is at speed. So I don't really like to do that. There's probably nothing that's going to happen with it, but it irks me to do that. So rather than bringing the engine back and shutting it down in the middle of the straights, and the fact that these were fairly new ECUs and that this was a sea trial, I didn't want to run the risk of having an issue that stalled an ECU in the straights that I wasn't able to fix. So bright me, I decided to leave it and wait until we got anchored, and that wasn't going to be an issue if we had an engine go down. So what happened is when we got anchored, I just shut the ECUs down. Probably mostly thinking that whenever I've run into this on past ECUs, all they require is a restart. They don't require you to tell it it's okay and then have it do it automatically. So I assume somewhere in the way Balder has this set up to push those changes to the ECU, there are required steps in there, and clicking OK on that that prompt, and then letting the ECU do it itself is one of them, which is unfortunate. And then what happened is I just power cycled the ECU and shut it down. It had corrupted the firmware. So basically, going back to my previous comment, I did something wrong, which caused this issue. And it's just because I didn't understand that it wasn't like other ECUs that I've worked with. It did require that step to be followed where you had to click OK. So yeah, that's my bad on that one, and I can guarantee you it's not going to happen again. Next question up, we've got from Rick Dunner 5181. Is the smaller new gen going to be an auxiliary generator? So I'm assuming you're referring to that little diesel engine that was sitting on top of my generator box. That's actually the full-size generators, and that's what runs my DC generator side as well. So it's a fairly small engine, and it will go to a fairly small AC generator. And the reason being is because I don't need a generator to run full load on pretty much any of my systems on the boat. My inverters are large enough to handle any of the loading on the boat. So I don't need a generator that handles peak loading all the time. And that's beneficial because A, I'm running the engine more efficiently, and B, it doesn't have to be bigger, so I'm typically going to get some small benefits in fuel burn. They'd be pretty minor, but as far as frictions, whatever, running a larger generator diesel engine versus the smaller one at a higher load. So there are benefits to doing it that way, and they take up less space. So there's benefits. And they're the same engines, so I don't have to carry different spares for the AC generator versus the DC generator on the diesel side. It's all the same engine. So basically what happens is the generator supplies enough where it overcomes the standard loading of the boat for electrical, and it can charge my batteries to full. And then the batteries and the inverters just handle the rest of it. And when I do the second generator, it is going to be an AC generator. So if I have an inverter failure, I can run systems off the AC generator. Maybe not peak loading, but then again, you don't have to. If I'm in an emergency situation, I can back off the other things, or where I don't have to run the water maker while I'm running the oven, things like that. So they don't have to supply the full load. They only have to supply the majority of what the boat is taking, or the excess enough to be able to bring the batteries back up to full charge. So they work quite well for that. And the inverters handle overload. So once the generator is attached, the inverters are going to a bypass, and they're bypassing the generator voltage through. The Victron equipment has the ability to do what's called power boost. So if I exceed the power that generator is able to put through, then the inverters will assist that. So even if I'm running high load on the generator, I can get like a 50% boost just from the inverters kicking in. So I don't have to be able to supply full load on the generator. Brilliant system. Okay, we got another question here, a good question from Kinsiler 9208. What's the cruising speed with one shaft locked out? Do you need a different type of mooring line to keep the shrimp off, or is that just an inevitable thing? Have you thought about having a thumb drive with the ECU program in case you need to reload the ECU? What are you going to use to insulate the generator exhaust so you don't accidentally get burned? I love seeing Janis dancing on the deck in her jammies. She gets pretty dancy when she gets happy on deck. And is that the first time Janis has ever caught Blaine pumping away below deck? Yes, it is. So we'll start with the first question there. Well, second answer. What's the cruising speed with one prop shaft locked out? From what I found is I basically lose 2 knots. So if we're doing 9 knots on 2 engines, if I shut one engine down, we're doing 7 knots. And I did some further testing with that, and the way that I've done it is I haven't locked the shaft out, because obviously I'll get a little bit more loss of speed with the shaft locked out, but I've pulled one engine back to neutral. So I've let that shaft freewheel, and I've just run the boat on one engine. So 2 knots there. So I've gone from 9 knots to 7 knots, and I haven't increased the RPM of the engine at all. It's still at 1500 RPM. And my fuel burn on that one engine went from 2.3 gallons per hour to 2.7 gallons per hour. So let's just say half a gallon per hour I increased on that engine, which is still below prop curve. And now I'm running on one engine. So I've lost 2 knots and I've increased the fuel burn by 4 or 5 gallons an hour, 0.4 to 0.5 gallons an hour. So obviously more efficient. I could run the boat that way and I would gain even more range. So there are certainly benefits to doing it that way. But you do obviously lose a little bit of speed on the boat. And quite honestly, I could probably crank the engine up, regain some of that back, probably all of it back. But you know what? Don't really need to run the engine that hard. I'm perfectly happy losing 2 knots if I ever needed to. So no issues with running it that way. And yeah, obviously benefits to be had. So next question, do you need a different type of mooring line to keep the shrimp off? Honestly, I don't think it'd matter what you put on there. I think they'd still get on there because there are so many little nooks and crannies where these things can grab on and hang on. And there's nothing they eat on the line. They're just hanging on there and grabbing nutrients from the water. So no, I don't think there's anything to do with that short of not leave it in the water, which for us at the time wasn't really an option. Okay, so we got the next question was, do you have a thumb drive? So I do have a thumb drive, and that thumb drive does have a file on there from each engine, whether it's the most recent file or not, unlikely, but it doesn't really matter because the only time that I would be using that is if I had a failure of the ECU and I had a failure of the file on there and I needed something just to flash back on to get me moving again, which would work just fine on that thumb drive. And then usually I would have the other engine, which would have a fairly up-to-date file on there, which would only require a couple of changes to work on the other engine. So there's some redundancy built in there. Plus there's a laptop per engine. So there's always going to have a file somewhere. To have all of that stuff go down where I wouldn't have a file would be a pretty rare circumstance. I did have someone recommend, and it was a great recommendation, cloud-based backup for that. And the benefit was for that would be, let's say we had a lightning strike and it fried every bit of electronics on the boat. I would have a backup file that I could put on that, a replacement ECU to get those engines back up and running again, which is pretty awesome. So I might start doing that. But for the time being, it's pretty robust for fail-safes, so not overly worried about it. Let's see. I think that's pretty much it. Exhaust insulation. I do eventually plan to do something like what we did with the main engines, preferably something a little bit more professionally done. Janis and I got the job done, but is far from a pretty or beautiful way that we've done it. It would require some sort of really nice blanket to go around the outside of it. And eventually I'd like to do something professionally with that, but for the time being it gets by. And even if I had to do something like that on the generator, it'd be pretty easy to do there as well, which we will probably eventually do. For right now, my insulation is just don't touch it, which isn't up to ABYC code, which currently I don't really care. But yes, it will eventually get done. So next question up here is from Mark Durand, U9Y. What's your fuel consumption rate with the Cummins engine? Thanks for sharing your trials and tribulations. Happy to do that. I've got nothing to hide, and if I make a mistake, I make a mistake, and I admit it. The fuel burn. So right now at our cruise speed, which is 99.999% of the time, we are burning at 1500 RPM and 9 knots, 2.4 gallons per hour is what it's worked out to be. And we've got, after this video was made, we've got tons of miles on these engines. So that's pretty well an accurate measurement, which is half of what the old engines did. And that's extensive time testing. And they do it quite well. And I haven't really had any other issues with these engines since. So yeah. 2.5 gallons per hour per engine. So 5 when we're underway at 9 knots. Now, one of the comments made on that specific question was from Dudley Dewright. And he said, He said 0.6 gallons per hour on one engine, likely 1 gallon per hour on both at gentle cruise, so maybe 10 miles per gallon. So maybe 5 miles per gallon at full speed, which must be around 25 miles an hour. So big issue there, not with what he said. He was correct with his, thinking anyway, with his math. Our gauges, the digital ones that I was getting those readings off of, were not properly calibrated. We found out shortly after we made this footage. The actual fuel burn is 2.5 gallons per hour, like I said, and it required me to recalibrate the digital side of things. So the way that I did that is my day tanks are square day tanks, so they're really easy to calibrate how much fuel is per inch on my my sight glasses. So what I did is I made marks on my sight glasses for every 10 gallons, and I can tell if I go for an hour and I see how much inches is on my day tank, I can figure out exactly what our fuel burn was for that hour. And what I've done is I've run the engines for several hours and I've averaged, so it's pretty accurate. And then I've gone back and recalibrated my digital gauges to represent what my mechanical eyesight sight glasses are showing me. So they are 100% accurate now and 2.5 gallons per hour per engine. Okay, next question we've got from Burned M9743. Blaine mentioned that he had no cell service, so are you considering a Starlink system or maybe a satellite phone for those remote areas? I would consider either one of these as a potential life-saving necessity. Long story short, I did answer that, I think, in one of the other earlier comments there. We do have Starlink, and I do now have Wi-Fi calling all set up. And to further that, with the Starlink and with our AIS, we are now able to offer real-time tracking, and we have that up on our website. So this isn't just whenever we're in range of a shore station. Whenever we have Starlink connection, we have real-time updates to our location. So not only is that great for people who want to follow where we are, it is great for life-saving and an emergency because they will know to the minute where we are. So yeah, we've got all that. There might be a time in the future if the channel ever gets big enough where we'll regret that. But for the time being, it's great, and it's about as good as we can get for safety and for people to be able to find us if we have an emergency. So yeah, that is in effect. And if you want to check that out, go to www.onboardtangaroa.com, menu in the top left, drop down, you'll see live tracking there. And that, like I said, is down to the minute or 5 minutes. So pretty accurate. Okay, next question up is from RVing since 2016. What did you find out about the transmissions? Do you need to lock the shaft? So if I remember correctly, what I found was that these engines were allowed to be run freewheeled with a caveat. They have to be filled completely with oil, like from what I understand, right to the top. And they have to be monitored for temperature because not only does the circulation pump not work when these transmissions are turning, but being there's no circulation of oil through the transmission coolers. So eventually they are going to warm up. Hopefully not enough to cause an issue, but if they do exceed a certain point, you have to lock them out anyway. So yes, we can, but we have to be really careful with how we do it. And so far I've not tested to see if that temperature will increase enough because quite frankly, I don't want to fill my transmissions right up with oil and have to drain it back out again when I don't have to. So yes and no, but they can be run a bit without being locked out. Okay, next question up is from Dudley Do-Right. He says, you need to get a drone. How can we fall in love with Tangaroa if we can't see her lines as she slices along the coast? Get a cheapest drone because they're easily lost, but she is a perfect drone carrier, plenty of area to take off and land. Can confirm. And many channels have tiny boats and have to catch their drones with their hands. Breakthrough footage though. So to answer that question, we do have a drone. We've actually got, well, at one point we had 3 drones and one recently took a dip in the drink. So it's no longer functional, but we've got a DJI Avata and a DJI Phantom 2, I think. And they all work great. We usually don't get a lot of footage on our refit channel. We have 2 channels. Refit channel usually doesn't need the use of a drone, but we do get drone footage on our exploring channel, which is exploring the world on board Tangaroa. I think we might be changing that around a little bit to make it easier to find. But for now, I think it's exploring the world on board Tangaroa, and there's lots of drone footage there. So check that out if you didn't know about it. And it's based around all of our travels with the boat. Focus is less on Tangaroa, more on where we're going with it, and stories that we find along the way. So if you like that stuff, check it out. Okay, next question up, or comment up, is from Hi There 7382. He says, have you ever heard of PCBWay and their competitors? If you can design something in CAD, they can make out of largely whatever material you want and mail it to you. I hadn't really ever used PCBWay before. I've used SynCutSyn before, but they don't do a lot of like CNC stuff. And I know that there's a lot out there, but I've never actually used any like the full-on CNC like hard part manufacturing places, mainly just sheet metal stuff or whatever. But that is a good reminder, and I might actually try some of those places. I do have a few custom things that I'm hoping to make up, and that might just work out pretty well for me. Okay, next question up is from ShoreSharp8349. Hey, Blaine, about ECU. Could you use a Holley ECU, Fuel Tech, Motec? I'm not familiar with electronic diesel hot rodding. Sorry if you have explained it in previous videos. There are certain ECUs. Holley, not one of them. Haltech, ECU Tech, all those guys. None of those guys can do common rail diesel engines. Motec's got some offerings. I think maybe EFI Technologies, possibly. There's a couple of other smaller brands that are less known that can do it. But the main stuff like Haltech, Link, Motec, or sorry, not Motec, Holley, they're not really set up for that. They are mainly based around gasoline engines or direct injection engines. And you could probably get away somehow with a GDI one, a gasoline direct injection ECU, but it wouldn't have the same functionality as what, say, the Balder ECU does. It's designed specifically around the common rail injection. You wouldn't get stuff like pilot injection, or if you needed it, post-injection, things like that. It just couldn't do. So yeah, it's specific algorithms that control that, and most don't have it. Okay, next question up is from Marty Sherry Griggs, 8136. I may have missed something, but why, when the main engines are running, do they not charge your batteries? So they do charge the batteries, just not the house batteries currently. My intention is to have a set of fairly hefty alternators on there because I have a fairly large lithium bank and it can charge at fairly high amperage. I think the standard rate is like 370 amps of 24 volt. And then it could fast charge quicker than that. I never do. So what I'm doing is running fairly large alternators. And the reason why I'm doing that is if I run, say, 2 big alternators, one on each engine, and when I say big alternators, I mean like these things are 95 pounds, they're huge, and they're made for continuous use. So if mine that I have are, I think, 320 amp alternators, they can pretty much continuously run 320 amps and live, which is more than I can say about most of the typical marine large frame alternators, definitely not the small frames. But even still, with these 2 big ones that I'm running, I will be running them at basically half capacity, which will just make them last longer. Less heat development, slower speeds, and still get plenty of airflow and run plenty cool enough. So yeah, that's what's going to happen. Right now I don't have those configured. For the time being, until I can get to that, because it's going to take a lot of fabrication, and like I said earlier in the comments, having some issues finding options for crank pulleys for these engines. So I'm likely going to end up with something custom, which is just a pain in the butt when you're dealing with pulleys. I have made custom pulleys on my lathe before. and it just takes a really long time, and I don't have my lathe anymore. So I've got to depend on a machine shop for that. So yeah, long story short, haven't got to it yet. I might do DC-DC converters off the standard truck alternators that came with them and just run really low amps, just enough to basically keep the batteries topped up when we're underway. Won't do big heavy charging though. So anyway, that's the plan. And currently I haven't got that done yet. Next question we've got, a good question from Nick Dial 8596. Could you have swapped the ECU that you wouldn't have to swap the alternator? I didn't actually have to swap the alternator. The only thing I had to do was run the field wires across from the port engine to the starboard engine. Quick and easy, wasn't a big deal. I think it took me all of like 10 minutes maybe to do. And the only reason why is because currently I've got one battery powering both engines, and I don't have a second alternator regulator for the second engine yet. So I've got one alternator charging the main 12-volt battery that's powering both engines. So eventually that's going to get two batteries, and each battery will be charged by its own alternator. They'll each have their separate regulator. And if I need to, I could cross over from one end to the other engine to another with just a bypass switch. But once again, that's something that I can do at any time. That didn't have to be done before we left the yard. So for now, that's just the way that I'm doing it. I've got some DC-DC chargers that keep everything topped up as well, just off of the main house bank. So that's not a massive issue anymore. So yeah, I'm slowly working through all those projects, but it's just a big list, and we like to enjoy the boat too. So I just work through those as we go. All right, got a pretty interesting question from OM16 Yoda 7. He's in the comments a lot. If you guys ever see him, he's got some good questions, and yeah, we enjoy it. And thank you very much for that. Do you ever get enough current while moored to spin the props? Was thinking of using them like water turbines to harvest some watts for free, but likely only practical on sailboats where you're moving relatively quickly without burning diesel. Love the troubleshooting, and Maggie is still cute with one ear up. Yeah, she's adorable. We love that dog. Short answer, no. We've never been in a location where there's been enough current to allow us to have a shaft spin and make power. The only time that would ever be possible is when we're underway, and like you said, it just doesn't make sense because nothing's free on a powerboat. There is no free energy. That being said, we've toyed around with the idea of possibly looking into kites for Tangaroa. That is I wouldn't say a new technology. Obviously, traction kites have been around for a while. That being said, they have started to get into providing this technology for bigger boats. They've looked into it for some ships. There's actually a company that's making them for reasonably sized vessels, I think like in the 40, 50 foot range. And there's no reason why this technology couldn't work on Tangaroa. We just have to have a kite that's big enough to do it. So maybe then we could run something where we could do some regen on the propellers. But for the time being, no, we really haven't run into any places where there's been enough current where we've been able to even spin the friction of the drive system, much less provide power afterwards. All right, guys, we finally made it to the end here. We're at the question of the day. We really appreciate you guys hanging out for the whole Q&A. Not entirely sure what we're going to do with this next week's video that's coming up. Unfortunately, I'm in Victoria. Janice is with the boat in Prince Rupert currently. And usually she's got those ideas, and I'm filming now and I don't have that info. So I'm not sure. It's going to be a surprise. But anyway, we've got down to the question of the day here, and it's from Unijabnix 2000. How does grounding work on a boat? I imagine that the DC negative is usually the aluminum frame of the boat, but if it is, how is the AC system grounded? Is it also using the hull as a ground? If so, is that safe / normal? So you have asked a question that opens up a ginormous can of worms. There are several different ways of doing the grounding on boats, especially steel aluminum boats, and there are very big proponents of each one of them, and each one of them will say that they have the correct way to do it. I am going the route of the protection of the aluminum hull. There will still be safety there, but we're going to cover a lot of that in probably a video sometime in January. We're going to be doing some fairly major electrical work on the boat in January. That's going to consist of rebuilding electrical panels, relaying out the wiring, things like that. So I'm going to be getting a little bit more into this. But basically, if I'm not mistaken, usually what's happened is no. The aluminum hull of the boat is not used for a ground, at least not in the sense that you think. It is not used for return path for DC electrical. That's a big no-no. And the DC power is less critical for keeping bonded to the hull because there's not really a safety factor involved with that. DC voltage on boats is typically low enough. You're dealing with 12 volt, 24 volt. I think 48 volt is kind of the limit to where they deem low voltage to no longer be safe. And don't quote me on that. It's been a while before I've done any reading on this, and I could be wrong on that. So don't listen to my info on this. Do that research yourself. And then typically what happens is the AC is safety grounded to the hull, as well as some way to get it out of the hull, like the shaft. So you have a path to ground. And there's major aspects with this. The reason why is, say, for example, you have grounding to the hull and you short yourself between the hull and a conductor. You want it to be able to trip safeties on that. Or sorry, I'm gonna go backwards there. Forget what I just said there. You say you have a short from the ground or the live wire to the hull somewhere, and you don't realize it, and somehow your body gets in contact with that. You have the potential of electrocuting yourself, fairly large potential. So what that ground path gives to the hull and through the bottom is it gives a path where if you get a short somewhere in the boat, it trips a breaker. So it is a large enough flow where it will trip a breaker. And there are also other items like residual current devices where they're very, very low amounts of current. I think 100 milliamps is the ABYC recommendation for a residual current breaker or ground fault breaker. So what that does is if it senses that the ground, or if there is not even ground, if the electricity coming into the boat, because it's AC, you have a supply and return path through the power and neutral or the two 240 volt leads. If it senses that the current going back to shore is not as high as the current coming into the boat, i.e. leakage, it trips that breaker. So if you put yourself between alive and the hull of the boat, it will hopefully trip the breaker to save you. Unfortunately, 100 milliamps is still higher than what the human body can safely pass. It will take much less than that to kill you, much, much less. I think the typical safe acceptable is somewhere around the 30 milliamp range. But funny enough, ground fault breakers typically aren't rated that low. There are specialty breakers that are, but then you start dealing with issues like nuisance tripping, where there's enough of something leaking somewhere to trip that breaker when it's not an issue. So there are all sorts of factors that go into this. And like I said, I am not a marine AC/DC specialist. I read about everything that I do, and I try to pick the best path for that. So yeah, these are some of the reasons behind it. And yes, there are some groundings. No, the hull is not used as a ground return path. But yes, there are days worth of reading that you could do into this to learn about it. And if you are planning to do anything like this on your boat, make sure you do read and that you have every bit of knowledge available to you, and even still maybe hire a professional, because there are things that you may not think about. So yeah, AC electrical, super high potential for devastating failure and life-threatening failure. So be careful with what you do with it. Yeah. Anyhow, that's it. Thank you very much, everybody, for the questions and answers. We appreciate every last one of them. As we say every week, that's what makes these videos possible. So stay tuned. And if you want to check out our exploring side of things, go to Onboard Tangaroa, the Never-Ending Sea Trial, or hit up www.onboardtangaroa.com, and it's got info in there as well. Thanks so much, guys. We'll see you next week.
If you like what we do and want to be a part of it, join our online crew. You'll get direct access to us on Discord, early videos, and crew merchandise. Supporting the channel this way helps keep the cameras rolling and the projects moving forward.